May 2nd, 1945, 2:22 p.m. Major Robert Staver of the U.S. Army stared in disbelief at the secret rocket arsenal within the Harz Mountains Mittelwerke factory. Before him lay hundreds of V-2 rockets, each one a technological marvel, decades ahead of anything America had conceived, 46 feet tall, weighing nearly 13 tons, capable of delivering a ton of explosives over 200 miles. Staver knew in that instant America had just stolen the future of space travel. These German rockets would be the vehicles to reach the moon. What Major Staver couldn't possibly know at that historic moment was that he was witnessing the greatest technological theft in human history. Operation Paperclip wouldn't just steal German rockets, it would also abscond with the brains behind them. Werner von Braun, Hermann Oberth, the geniuses who had made the impossible possible, would be forced to realize American dreams. The story of the German V-2 doesn't begin with war, but with a dream of space. In 1929, Hermann Oberth founded the Society for Space Travel in Berlin. Young enthusiasts, like Werner von Braun, experimented with liquid fuels and dreamed of journeys to other planets. These pioneers developed the theoretical foundations of rocketry, while American scientists still considered rockets to be nothing more than science fiction. In 1932, von Braun's team demonstrated their first successful liquid-fueled rockets to the German army. The military immediately recognized the potential, a weapon that operated beyond the range of enemy artillery, uninterceptable and precise. In 1937, construction began on the secret Peenemünde Rocket Research Station on the Baltic coast, the birthplace of spaceflight. The technical challenges were unimaginable. A rocket intended to climb 60 miles high required engines with 55,000 pounds of thrust. The combustion chamber had to withstand temperatures of nearly 5,000 degrees Fahrenheit. The guidance system had to be precise enough to hit a target nearly 200 miles away. Americans and Brits didn't even remotely possess the technology for such endeavors. The V-2 used liquid oxygen and ethanol as fuel, a combination that consumed 2.5 tons of propellant in just 65 seconds. The turbo pump that enabled this enormous fuel flow generated 580 horsepower, a masterpiece of German precision engineering. A single V-2 consumed more high-grade alcohol than an entire German city in a month. The V-2's guidance system was revolutionary. 3 gyroscopic instruments controlled its trajectory with a precision that wouldn't be matched for decades. The analog computer system continuously calculated speed, acceleration, and course. This technology was the direct precursor to all modern navigation systems, from GPS to smartphone sensors. October 3rd, 1942, the first successful launch of a V-2 took place at Peenemünde. The rocket reached an altitude of 52 miles and a range of 91 miles. Werner von Braun commented prophetically, "Today, the spaceship was born." What he didn't know was that Allied spies were already photographing every rocket launch and systematically analyzing the German technological superiority. Mass production of the V-2 was both an industrial marvel and a human nightmare. In the underground Harz Mountains Mittelwerke factory, 60,000 people worked around the clock. German engineers developed innovative manufacturing methods for precision parts on an industrial scale. Each V-2 consisted of over 20,000 individual parts, manufactured with tolerances of less than 0.04 inches. The V-2 wasn't just a weapon. It was the first practical spacecraft in history. It regularly broke the 62-mile boundary into space, reached speeds of over 3,000 miles per hour, and proved that manned spaceflight was fundamentally possible. American rocket scientists were still years away from even understanding the basics. The technological lead was overwhelming, while the V-2 was already reaching space. American researchers were still experimenting with primitive powder rockets, with ranges of just a few miles. Robert Goddard, considered the father of American rocketry, had only reached an altitude of 1.6 miles by 1945. The V-2 flew 30 times higher. When Allied troops reached Peenemünde in 1945, the research station had already been blown up. But in the Mittelwerke, they found the greatest technological treasure in history: hundreds of complete V-2 rockets, thousands of tons of spare parts, complete manufacturing facilities, and detailed construction drawings. Major Staver immediately ordered, "Take everything that isn't nailed down." Operation Paperclip had been planned long in advance. As early as 1944, the American Joint Intelligence Objectives Agency had created lists of German scientists who were valuable to American interests. Werner von Braun was at the top of this list. His abduction to America was already a foregone conclusion before the war even ended. On May 2, 1945, Werner von Braun voluntarily surrendered to American troops. He knew the alternative: imprisonment by the Soviets and decades of forced labor in Siberian rocket labs. Von Braun chose the gilded cage of America, where he could realize his space travel dreams, albeit under the American flag. The Soviets were more systematic. They dismantled entire factories and transported them to Russia. German engineers, who couldn't escape in time, were deported with their families. Sergei Korolev, the father of Soviet spaceflight, built his entire program on German technology and German engineers. 300 railroad cars full of V-2 parts reached the USA in 1945. 127 German rocket scientists were transported to Fort Bliss in Texas. They received American identities, American salaries, and the mission to make America the rocket superpower. Their Nazi past was systematically obscured and erased from the records. The first American rocket was a German V-2 on April 16, 1946. A captured V-2 was launched from White Sands, New Mexico, and reached an altitude of 68 miles. American media celebrated it as an American triumph, but concealed the fact that German engineers had built and launched the rocket. The technical specifications of the V-2 were a mystery to American engineers. The combustion chamber made of a special steel alloy, the cooling system design, the fuel injection technology, everything was years more advanced than American technology. It took NASA engineers a full decade to completely understand and copy these German innovations. Werner von Braun was stylized as an American hero, but his first rockets were pure V-2 technology. The Redstone rocket of 1953 was essentially an enlarged V-2. The Jupiter rocket used the same basic principles. Only the Saturn rocket surpassed von Braun's German designs, but even they were based on V-2 foundations. The space race between America and the Soviet Union was actually a competition between German engineers. Von Braun in America against his former colleagues in Russia. Both sides used German V-2 technology as a starting point. The only difference: the Americans never admitted it. October 4, 1957. Sputnik shocked the world. The Soviet R-7 rocket, which launched the first satellite, was based directly on German V-2 technology, developed by abducted German engineers. America realized, without its own space technology, it would lose the space race. The founding of NASA in 1958 was essentially the renaming of Werner von Braun's German team. From 1945 to 1960, practically all American rocket successes were German successes. The Apollo program that took America to the moon was von Braun's life's work. Financed with American billions, but built on a German foundation. The Saturn V, the most powerful rocket in history, was von Braun's masterpiece. Its 5 F1 engines together produced 3,400 tons of thrust, more than all the V-2 rockets of the war combined. But the basic principles were the same: liquid fuels, multi-stage design, computer-controlled navigation. July 21, 1969. Neil Armstrong stepped onto the moon. In that historical moment, German rocket engineers stood in the NASA Control Center and saw their dreams realized. What had begun as the V-2 project in Peenemünde brought humanity to other worlds. Operation Paperclip was completely successful. The irony is perfect. America celebrated the moon landing as its greatest triumph, but German technology and German engineers made it possible. Without the stolen V-2 rockets and abducted scientists, America would have lost the space race. The Soviets won Sputnik with German technology. America won the moon with German engineers. Modern space travel continues to build on German V-2 foundations. SpaceX Falcon Heavy, NASA Artemis, ESA Ariane, all use principles that Werner von Braun developed in Peenemünde: liquid fuels, reusable components, precise navigation systems. German engineering from 1940 shapes the space travel of 2025. These stories aren't just forgotten history or dusty archives. These are the foundations of our modern spacefaring civilization. Every satellite, every space station, every interplanetary mission works on principles that German engineers invented 80 years ago. Real innovation, real genius, real consequences for all of humanity. If these technical truths are important to you, then support with YouTube's Super Thanks, the golden heart below. Every Super Thanks enables me to dig deeper into archives, to digitize rare blueprints, to interview surviving engineers who witnessed this history firsthand. Help me preserve this technical history for coming generations. The V-2 was more than a weapon. It was the cornerstone of the space age. German visionaries like Hermann Oberth were already dreaming of trips to Mars in the 1920s, while the rest of the world considered rockets as mere fireworks. This foresight, combined with German precision and engineering, created the technical basis for everything that would follow. The V-2's engine was a marvel of combustion technology. The combustion chamber reached temperatures hotter than lava, while the walls were kept below 200 degrees C through regenerative cooling with the fuel itself. This cooling technology is still used in all modern rocket engines. From SpaceX to Chinese moon rockets, the material science of the V-2 was revolutionary. German metallurgists developed special steel alloys that could withstand the extreme conditions of combustion. These materials were so advanced that American engineers took years to analyze and reproduce them. Modern superalloys for jet engines are based on these German developments. The production logistics were as impressive as the technology itself. Over 700 supplier companies throughout Germany produced V-2 components to the most exacting specifications. This decentralized manufacturing, with central quality control, became the standard for all complex technologies, from automobiles to modern smartphones. Operation Paperclip went far beyond rockets. American teams also stole German developments in jet engines, radar systems, computer technology, and even medicine. The entire American technological lead of the 1950s and 1960s was based on German know-how. Without this systematic plundering, America would not have become a technological superpower. The human costs are often overlooked. German scientists were effectively made prisoners of war, forced to work for American goals. Their families were held hostage to guarantee cooperation. Many German engineers dreamed their entire lives of returning to Germany, but were never allowed to visit their homeland again. The legacy of the V-2 extends to this day. Every rocket launch is based on German principles from 1942. The International Space Station ISS was reached with rockets that use German technology. Mars rovers are launched with carrier rockets that implement von Braun's concepts. German engineering from wartime enables modern space exploration. The future of space travel will continue to stand on German foundations. Planned Mars colonies, moon mining, interstellar probes all require rocket technology that is based on V-2 principles. The next generation of German engineers is already developing reusable rockets and revolutionary propulsion systems for the next phase of space exploration. The technical specifications of the V-2 in detail reveal the full extent of German engineering superiority. The rocket was 14.03 meters long and had a diameter of 1.65 meters. Empty, it weighed 4,000 kilograms, fully fueled 12,900 kilograms. This mass-to-performance ratio was so optimal that modern rockets still strive for similar ratios today. The A4 engine of the V-2 produced 245 kilonewtons of thrust with a specific impulse of 203 seconds. To put it in perspective, Robert Goddard's best rocket from 1941 achieved a mere 500 newtons of thrust. The V-2 was 500 times more powerful. This enormous leap in performance was only possible because of German innovations in fuel chemistry. The fuel mixture was revolutionary: 8,400 pounds of liquid oxygen as an oxidizer, and 11,000 pounds of 75% ethyl alcohol as fuel. This combination was optimal for high-performance combustion and could be stored at temperatures of -297 degrees Fahrenheit. American rockets were still using primitive powder propellants with fractional efficiency. The turbopump system was a masterpiece of German precision engineering. The main pump was powered by an auxiliary steam turbine, delivering 160 horsepower and reaching 3,000 RPM. This system could pump 275 pounds of fuel per second, a flow rate that American engineers wouldn't achieve until the 1960s. The combustion chamber design was groundbreaking. 18 injectors distributed the fuel evenly, while a double-walled cooling system managed the extreme temperatures. The alcohol fuel circulated through the combustion chamber walls, cooling them from nearly 5,000 degrees Fahrenheit to below 400 degrees Fahrenheit, a technique that is now standard in all high-performance rocket engines. The guidance system was revolutionary for its time. 2 gyroscopes and an accelerometer controlled the trajectory, while graphite vanes steered the exhaust nozzles. This analog computer system was so precise that it could hit targets 200 miles away with an accuracy of just 2 to 3 miles, an accuracy that American systems wouldn't reach until the 1950s. The aerodynamics of the V-2 were perfectly conceived. The conical tip reduced drag at supersonic speeds, while 4 stabilizing fins kept the rocket stable, even at extreme velocities. These design principles were later adopted by all modern rockets, from the Atlas to the Ariane. The manufacturing quality was typically German. Every weld was X-rayed, every component was individually tested, every tolerance was checked to 1/100th of a millimeter. This quality assurance was essential for success. A single defective seal could have destroyed the entire rocket. German standards established manufacturing methods that are now universally applied in aerospace. Operation Paperclip was meticulously organized. American teams received detailed lists of German scientists, ranked by priority and specialization. Werner von Braun was at the top as a first priority target, followed by Hermann Oberth, Walter Dornberger, and hundreds of other rocket engineers. The operation was planned well in advance and executed with military precision. The transport logistics were astounding. 341 complete V-2 rockets were disassembled into individual parts and shipped to America. 14 complete engines, 200 turbopumps, 500 guidance systems, thousands of tons of specialized steel. Everything was systematically catalogued and transported to Fort Bliss. This loot was worth more than all the German gold reserves combined. The German engineers were treated like prisoners of war, but with golden handcuffs, luxurious accommodations, American salaries, but constant surveillance. Their mail was censored, their movements were monitored. Their families were held as collateral. Escape attempts were punished with immediate deportation back to the Soviets. Fort Bliss was effectively a prison for geniuses. 127 German scientists worked there under strict secrecy on the development of American rockets. They were not allowed to publish articles, give lectures, or have contact with German colleagues. Their entire knowledge now belonged to America. The first American rocket tests were embarrassing. Of the 67 V-2 rockets launched between 1946 and 1950, 27 exploded on the launch pad or shortly thereafter. American engineers didn't understand the German technology and made primitive mistakes in maintenance and operation. Without German supervision, even more launches would have failed. Werner von Braun was built up as an American icon, but his true story was obscured. His SS membership, his use of forced labor, his fanatical Nazi ideology. All were erased from the records. Hollywood portrayed him as a sympathetic scientist who only dreamed of space. The truth was more complicated and darker. The Redstone rocket of 1953 was von Braun's first American development. In reality, it was a direct evolution of the V-2, with extended burn time and improved control. Of the 60,000 individual parts of the Redstone, over 40,000 were direct V-2 derivatives. America sold German technology as American innovation. The Jupiter rocket went a step further. It used V-2 engine technology, but in a completely new design. 4 engines instead of 1, clustered in a novel arrangement. This configuration was later adopted for the Saturn rockets and enabled the enormous thrust needed for lunar missions. The Atlas rocket, America's first intercontinental ballistic missile, was also based on German foundations. Its staging technique, the engine design, the fuel systems. All were further developments of V-2 concepts. Without Operation Paperclip, America wouldn't have had intercontinental missiles and could have lost the Cold War. The Mercury program, America's first step into manned spaceflight, was entirely dependent on German technology. The Redstone rocket launched Alan Shepard into space. The Atlas rocket carried John Glenn into Earth orbit. Both rockets were German technology with American flags. A triumph of German engineering under foreign direction. The Apollo program was von Braun's life's work and simultaneously his legacy. The gigantic Saturn V was the realization of his childhood dreams of lunar missions, funded with American billions, but built on German principles. Each of the 3 stages used technologies that were directly based on V-2 developments. The first stage of the Saturn V, with its 5 F1 engines, was a scaled-up V-2 concept. The same fuels, the same combustion technology, the same cooling concepts, only in gigantic dimensions. Each F1 engine produced more thrust than 30 V-2 rockets combined, but the underlying principles were identical. The guidance technology of the Saturn V was a direct evolution of the V-2 gyro navigation. Instead of mechanical analog computers, it used electronic systems, but the mathematical algorithms and control principles were the same ones that German engineers developed in 1942. July 20th, 1969, 8:17 p.m. UTC. Neil Armstrong took his first steps on the moon. In this historic moment, the German V-2 rockets concepts achieved their ultimate triumph. The rocket that carried humanity to the moon was the realization of Werner von Braun's Peenemünde dreams, financed by America, but at its core, completely German. The Soviets won many of the early battles of the space race with the same German technology. Sergei Korolev, their chief designer, worked closely with deported German engineers. The R-7 rocket, which launched Sputnik and Yuri Gagarin into space, was a direct evolution of the V-2 rockets, enhanced with Soviet improvements. The irony was perfect. The space race was, in reality, a competition between German engineers on different sides. Von Braun in America versus his former colleagues in Russia. Both starting from the same V-2 rockets foundation, both fighting for foreign flags. Germany had lost the war, but German technology conquered space. Modern SpaceX rockets still use V-2 rockets principles. The Merlin engines of the Falcon 9 utilize the same regenerative cooling, the same fuel combinations, the same turbopump technology. Elon Musk's dreams of Mars are built upon foundations laid by Werner von Braun 80 years ago. The next generation of space travel will continue to build on German V-2 rockets' fundamentals. NASA's Artemis program for the return to the moon, SpaceX's Starship for Mars colonies, Blue Origin's New Glenn for commercial spaceflight. All use technologies that have their origins in Peenemünde in 1942. The European Space Agency, ESA, is in some ways the return of German rocket technology to Europe. The Ariane rockets use the most advanced versions of the V-2 rocket's basic concepts, developed by successors to the original German rocket pioneers. Germany is, once again, a leading spacefaring nation. Private space companies like Virgin Galactic, Blue Origin and Rocket Lab are all building on German V-2 rockets technology. The commercialization of space, which is becoming a reality today, was already included in von Braun's original visions. He dreamed of routine space flights for everyday folks, a dream that is now coming true. Interplanetary missions to Mars, Jupiter and Saturn will all be launched with rockets that use German principles. The Voyager probes, which are now leaving the solar system, were launched with Titan rockets, direct descendants of the V-2 rockets technology. German engineering is already exploring other star systems. The future of space travel will bring new technologies like ion drives and fusion rockets, but even these will rely on launch systems based on German V-2 rockets concepts. Generation ships for interstellar travel will be launched with rockets that carry on Werner von Braun's legacy. The legacy of the V-2 rockets is bigger than just rockets and space travel. It proved that technical visions can become reality when science and engineering work together. It showed that seemingly impossible dreams can be realized with German thoroughness and precision. The V-2 rockets also established entirely new manufacturing standards for high-precision technology. The welding techniques for the fuel tanks required temperatures of exactly 1700 degrees, controlled to within 5 degrees of accuracy. This precision was necessary to manage the enormous pressures of 20 bar in the fuel system. Modern aerospace still uses these German welding procedures. The material science of the V-2 rockets was groundbreaking. German metallurgists developed special chromium steel alloys for the combustion chamber, alloys that could withstand both extreme temperatures and corrosive fuels. These materials were so advanced that American companies had to purchase licenses for German steel patents well into the 1960s. The quality control was revolutionary systematic. Every V-2 rockets underwent 127 separate testing steps before deployment. X-rays of all welds, pressure tests of all lines, functional tests of all electrical systems. These total quality management principles were later adopted by the Japanese automotive industry and are now considered standard. The testing methods established new scientific standards. German engineers developed high-speed cameras that could capture 10,000 frames per second to analyze engine combustion. This technology was adopted by Hollywood for special effects and by the automotive industry for crash tests after the war. The fuel chemistry of the V-2 rockets influenced the entire petrochemical industry. German chemists developed methods for the mass production of high-purity ethyl alcohol and liquid oxygen. These production methods were adapted after the war for the manufacture of plastics, pharmaceuticals, and other chemical products. The electronic systems of the V-2 rockets were years ahead of their time. The radio remote control system used UHF frequencies with a range of over 300 kilometers, a technology that only became available for civilian applications in the 1950s. These developments laid the groundwork for modern television and mobile communication technology. The aerodynamic calculations for the V-2 rockets required mathematical models that pushed the limits of computing technology at the time. German mathematicians developed new numerical methods and mechanical calculators to perform complex flow calculations. These methods were later used for the development of jet aircraft and automobile bodies. The logistics of the V-2 rockets' production revolutionized the manufacturing industry. Just-in-time delivery from over 700 suppliers, central quality control, modular construction for easy assembly, all concepts that were only celebrated as modern manufacturing methods decades later. Toyota and other Japanese manufacturers studied German war production methods for their own systems. The V-2 rockets' development also led to breakthroughs in measurement technology. German engineers developed pressure sensors that could detect millisecond fluctuations in fuel lines, temperature sensors for 3,000 degrees Celsius environments, accelerometers with 0.01 G accuracy. These instruments were adopted after the war for aviation, the automotive industry, and mechanical engineering. The safety systems of the V-2 rockets established new standards for high-risk technology. Automatic engine shutdown in case of anomalies, self-destruction mechanisms in case of loss of control, emergency venting in case of fuel leaks. These concepts were later adapted for nuclear power plants, chemical factories, and other hazardous industrial facilities. Operation Paperclip also had unintended consequences for the American industry. German engineers brought more than just rocket science to the table. They also brought production methods, quality standards, and management techniques. American companies, giants like Boeing, Lockheed, and General Motors, benefited enormously from this indirect transfer of technology. The medical research conducted during the V-2 rocket's development led to major breakthroughs in aerospace medicine. German scientists pioneered the first G-force simulators, high-altitude pressure suits, and oxygen systems designed for extreme environments. These technologies, down the line, saved thousands of pilots' lives and paved the way for manned spaceflight. It's kind of amazing. And get this, V-2 research revolutionized weather forecasting too. German rockets were the first to reach altitudes where direct measurements of the upper atmosphere became possible. The data they gathered, air pressure, temperature, wind speeds at altitudes of over 60 miles, dramatically improved weather models. Communication technology also saw a massive leap forward. The V-2 employed radio links capable of penetrating the ionosphere, a technology that later became essential for satellite communication and GPS systems. Without these German breakthroughs, the telecommunications revolution could have been delayed by decades. Now, the V-2's computer technology might seem primitive by today's standards, but it was revolutionary for 1942. Analog computers continuously calculated trajectory corrections based on sensor data. This real-time data processing was a precursor to modern embedded systems. the kind you find in cars, airplanes, and smartphones. Everything, even environmental technology, had to be reinvented for the V-2 rocket. We're talking about systems for treating highly toxic fuel vapors, noise reduction for engine tests, vibration isolation for sensitive instruments. These technologies were later adopted by heavy industry, power plants, and environmental protection facilities. Talk about unintended consequences. The V-2 even influenced architecture and civil engineering. The underground production facilities demanded innovative methods for constructing large caverns, ventilation systems for chemical fumes, vibration-free foundations for precision machinery. These construction techniques were later applied to subways, tunnels, and bunker complexes. It's all connected. The training methods for V-2 technicians established new standards for technical education. Systematic training programs, hands-on laboratory work, continuous professional development. These were all concepts that were later adopted by technical colleges and industrial companies worldwide. And here's a kicker. International standardization in rocket technology is largely based on V-2 specifications. Dimensions for fuel lines, threads for high-pressure connections, testing procedures for engines. Many international standards can be traced directly back to wartime German developments. So, what German technology surprised you the most? We know there are engineers in the comments with amazing connections, grandfathers who worked with Werner von Braun, NASA documents with German origins, modern rocket patents that have roots in the V-2. Share your space exploration discoveries. Every comment is a piece of space history that we can preserve together.